Example 1, adding a constant to a function. To regulate temperature in a green building, airflow vents near the roof open and close throughout the day. Figure 3, this figure right here, shows the area of open vents V in square feet throughout the day and hours after midnight T. So what you're looking at before we finish the rest of the sentence here, okay, we have V of T, where T is the hours after midnight. Now, during the summer, the facilities manager decides to try to better regulate temperature by increasing the amount of open vents by 20 square feet throughout the day and the night. We want to sketch a graph of this new function. So if you take a look at the original function, which was in blue, we wanted to increase the open vents by 20 square feet. So if you notice, we're moving up this entire graph 20 feet. So here we have S of t, which is equal to V of t, which is this function. And what we're doing is that we're adding 20 now to the function V of t. So you can see how this entire graph now in red has shifted up 20 units. So we can sketch a graph of this new function again by adding 20 to each of the output values of the original function. This will have the effect of shifting the graph vertically up, as we can see in figure 4. And now notice that in figure 4, for each input value, the output value has increased by 20. So if we call the new function S of t, we could write S of t, which is equal to V of t plus 20. This notation tells us that for any value of t, S of t can be found by evaluating the function v at the same input and then adding 20 to the result. This defines S as a transformation of the function v. So in this case, a vertical shift up 20 units. Now notice that with a vertical shift, the input values stay the same and only the output values change. So let's take a look at this. So if you look at the first value here, we have 0, 0. Okay, now in the next part, we shifted it up 20 units over here. So what we've done is we've added 20 to the y value in order to get the output now of 20. Okay, let's take a look at another ordered pair. We have 8, 0. So that is the first ordered pair. Now over here, you can see to the right that we shifted it up 20 units. And if we shifted up 20 units, we still have 8 as the input. When we add 20 to 0, we get 20. Now let's take a look at the next input that we have. We have 10 and then 220. So at 10, here's 10 in the middle. And up here is the value of 220. So we're still going to have the same input of 10, but now we need to add 20 to that output. So if we add 20 to the output, we get 240. So let's take a look here. So here's the value of 10, and now we shifted up 20 units to get 240. Let's take a look at the next input. We have 17. So if we take a look at 17, and it has an output of 220, excuse me. And so if we take a look at 17 again as an input, on the other graph, we're going to be adding 20 to 220 to get 240. So let's locate 17, which is right after 17 here. And again, we're shifting it up 20 units at 240. Okay, let's take a look at the rest of them. So we have another input at 19, and it has an output of 0. So if we take a look at that input of 19 and an output of 0, well then what happens when we have the same input of 19, we add 20 to it? So again, as you can see here, at 19, we shifted it up 20 units. And then again, for the last one, we have 24 and 0. So if we take a look at our graph, over here there's 24 and there's 0. And then again, what we're going to do is we're going to shift that up 20 units by adding the output by amount of 20. And so therefore, we shifted it up 20 units. So again, that is your vertical shift of 20 units.